Okay, part 2. Next thing we're going to do is a focal statistic to smooth our DEM. This I did by mistake. Alright, so we have our projected raster. The next thing we want to do is smooth this out a little bit so it's not quite so jaggedy for our contours and for our hill shade. So, the way we want to do that is with a focal statistic. And just to remind everybody, or if people have not used focal statistic before, essentially what it is, we'll put in our input raster. Our output will be smooth, DEM. And basically what we're doing is we're sending a box of 9 cells to each cell in the raster, and then it's going to calculate the mean value of those 9 cells and then rewrite that to each individual raster. So it's a moving window that basically takes the mean value of whatever that defined window is. In this case, we'll do a 3x3 window. And you can make this rectangle, you can make it circle, weighted in particular ways, irregular in particular ways. And by using the mean statistic, you can take the sum value, the maximum value, the minimum value, etc. The mean value will simply average out and smooth your raster. Let's do that. So it's basically each cell in this raster is going through and just finding the mean value of its neighbor cells one by one. And what that gives us, we'll get rid of the projected one, gives us a smooth raster. Alright, now let's go ahead and create some of our export layers, our hill shade and our slope. Slope, smooth DEM. I'd already made a slope and a hill shade that were in the incorrect order before I had smoothed the DEM. So I'll just call this one Slope 2, which is bad naming practice, but oh well. Alright, that looks good. Let's go ahead and hit that. That's going to pop us out with our slope raster. These are basically just degree of slope, right? So the green areas are essentially flat to the red areas, which are quite steep, between 40% and 77% gradients. So we'll go ahead and symbolize this differently. Instead of this classified, it's stretched. Let's give the standard deviation 4.5 just to stretch those values out a little bit further. We want to do white to dark. So our low slope areas, our low slope areas are white and our high slope areas are dark, stretched across an extended histogram where it goes out 4.5 standard deviations instead of 2.5 standard deviations. That's good. Let's go ahead and export this. So we're going to export this slope layer here as slope.png 300 dpi. Since the white values represent low values within the slope, we're just going to keep that as white for now. All right. That looks good. And go ahead and get rid of this. We don't need it anymore. And now we'll do our hillshade. Defaults are good here, 315, 45. We go back and create our DM, or create our hillshade, create our slope from our DM. The next thing we'll do is create that aspect raster and reclassify it. And this is not simply the symbology of this reclassify, but we'll actually use the reclassify to create new raster. I'll show you guys how to do that. Alright, so we created a hillshade. This resolution is a little spotty, but when I do my map in Photoshop, I'll probably zoom into about this region. I might have to smooth it just a little bit. It's a little choppy, but it's not too bad. Right. So I will go ahead and export my hillshade here. I don't need that anymore either. Okay. The next thing we're going to do is do an aspect. Again, what this is doing is just going through our DM and looking at which direction each cell faces within a compass, 360-degree outlook. Planar, all good there. Alright, so now you can see our aspect. You can see, north is generally, right, 337 degrees to 22.5 degrees, northeast, etc. And so what we want to do is actually kind of clump some of these together. What's going on here? Got some weird artifacts up here. Ah, interesting. Okay, well, let's see how it looks. Alright, so let's go ahead and reclassify this raster. Right, reclassify spatial analysis tool. Our input raster is going to be this aspect. And let it build up its histogram here on the bottom. Okay. And so we're going to want a total of 4 classes here. Oh no, 1, 2, 3, 4, 6 classes that will go into 4 classifications. Let's just go ahead. The easiest way to do that, put it on 6 here. Put this at -1. back out our list. All right, then we want 1 to 112.5 to be 1. 112.5. So 0, 112.5, 157.5, 292.5, 337.5, and then 360. Okay. The reason I do it in here, you can also do it through this class here, this classification. You have to make sure you have a space between the value, space, dash, space, value. So it can get kind of annoying, actually. All right, this into 0. This will be 1, 2, 3, 1, 2, 3, 2, 1. All right. Shit. So that's what happens when you go too fast. So put my number, space, dash, space, 360. That is 1. The thing that's annoying about using this reclass tool is if you mess up, then you basically have to start all over. Call it reclass. Okay, so now we can see that we have these values. 0 equals flat, 1 equals north, east basically, 2 encompasses both southeast and northeast, no, southeast and southwest. 2 is our eastern, so basically 1 is going to be our shadow side, 2 kind of neutral, and 3 our illumination side. Okay, let's get rid of this guy. So this is what you should look like now. All right, the next step, go back to here. We want to vectorize raster to polygon. And since, we're not hugely concerned about this kind of weird artifact area right now, we want to vectorize this and then attach it to the contour. Since this is flat, there's not going to be any contours there. So it's all going to get kind of washed away. So it's not, I don't think it's going to be a big deal. All right, so raster to vector. Raster to polygon. All right, so raster will be reclass, value, let's call this feature class vector aspect. That's good.